24. We're almost done. Is there a proportional relationship day 2? This is what we started with yesterday. So we're on page 24. Okay, so the first thing you have to do is you have to plot the points. So go ahead and plot these points on the graph.
22nd today, right?
23rd.
23rd?
Yeah, but we don't have to fill that out. All right, so let's go ahead and focus on page 24. All right, so we're graphing it. It is a straight line, right? It does not go through the origin. So, is there a unit rate? No. Is there an equation? No. It's because it does not go through the origin. Is it a straight line? Yes. So, is it proportional? No. So, in what situations is this? Have you guys ever been to the fair during the summer?
Yes.
So, in the fair is a perfect example of this. Because do they charge you just to get in?
Yeah.
Yes. So the fair, they charge you to go in, right? Do they charge you again for the rides?
Yeah.
Yes, right? So this is like, if they charge me, let's pretend, $2 to get into the fair. And then if I want to ride one ride, they're going to charge me $3. If I want to ride two, they're going to charge me a total of $4. If I ride 3 rides, I get to pay in total $5. But what if I ride 0 rides? I don't want to get on those.
You still pay $2.
I still pay $2, right? Yeah, those are scary rides.
What about the food?
Last time we got on it, and I low-key felt like my seatbelt was like, and I
Yeah.
was so scared, I literally started crying.
Honestly, man, I really
Yeah, no.
want it.
Fair.
I'm not going past
No.
the DLC first, bro.
All right.
Oh, that's not
So
Bro, I want to miss riding.
this is an example of they just charge you, but you're not doing anything. You just to get in. And then, for example, if you want to ride a ride, then they'll charge you more. The ride price is constant, but yeah.
Only thing fun there's like the bumper cars. I'll go there and drift.
Yeah.
All right.
Because they built them.
Let's graph number 2.
Bro, I'd be drifting in the bumper cars.
Let's graph number 2, everybody.
Mernie. Bro, I did bumper cars. There's like a mascot in there, bro. There is a mascot in the bumper cars.
Okay, graph it.
Don't be my fault.
Rub it up. Nah, that was proportional.
Dude, I was laughing when he said that. Wait, I think, does it go through origin?
Yeah.
Yeah. So it's proportional.
Wait, was it on light?
Yeah,
Wait, I want to see the video.
The unit rate is 1.5, right?
You looked at my rate.
But what's the unit rate?
All right. What did you multiply to x to get to y?
Hey, you liar, liar.
Yes?
It's not, the unit rate's not 3 because it goes in by 2. The x goes up by 2. So when
Each get added. Multiply by 2.
the unit rate, wouldn't it be,
No, 3 goes
it's a straight line.
Okay.
The unit rate, wouldn't it be 1.5? So it wouldn't
That's what I was thinking.
because you can't, yeah.
So let's answer the easy ones. Does it go through the origin?
Yeah.
Yes. Dylan? Is it a straight line? Yes. Okay, so it's proportional. So if it's a yes, we can go back and answer these 2 things. Basically, the unit rate is where the 1 is. But it seems like it's not in a corner, right? If I look here, if I look at the 1, it is totally not in a like perfect 1, 1, 1, 2, right? It's going to be a decimal. Is it the 1? Is there a dot here on the 3?
No.
No, right? So our unit rate is not 3. Our unit rate is this. But obviously, it's not in a like perfect little corner, gentlemen. Stop with the rulers. All right. So here's what you do. Unit rate is basically what did you multiply 2 to get to 3? The same number, 4 times what is 6? 6 times what is 9? 8 times what is 12? So we're looking for this magical number that we multiplied all of these numbers by to get to this. And if we don't know, this is not an easy one for a lot of students, so you're going to divide. You pick any of these pairs. What letter goes outside? X. What letter goes inside? Y. It's in alphabetical order. X, Y, Z. Juan? So you pick any pair. I would always go for the smaller ones, or if there's a 5. So 2 goes into 3 how many times? 1. That gives me 2, remainder 1. Add a decimal and a 0. How many times does 2 go into 10? 5. So that means that my unit rate is 1.5, which a lot of you did tell me before because you saw it, which was fantastic. If you don't see it, then you end up dividing. Sometimes it's easy to do mental math, and sometimes it's like, wait, I don't know what it is.
Y
Y equals 1.5x. Very good. All right, go ahead and get started on the next one.
Can I call him the J word? Finish it up.
It does go through the point of 4. It is 3.
1, 2, 2, 4, 3, 6, 4, 8, 5.
Oh, it's the last page.
1.
27 is the last. 26. 27 is the last page.
All right. So it seems like goes to the origin. It seems like it's a straight line. Yes. So that means you look back. Oh, well, always if you have the x is 1, then you have your answer. Because when x is 1, whatever y is, that's your unit rate. So here's my x. It's 1. Yay, time to celebrate because this would be my unit rate. So that it means that I'm going to multiply 1 times 2. Did I multiply 2 to all of these?
Yeah.
Yep. So that means my unit rate is 2. What's my equation? So if they give you the 1, dude, it's so much easier. All right, next one. Oh, we forgot to delete equate its unit rate.
It
1,
doesn't
2.
matter because it doesn't go through the origin.
Why is there's 2 equations?
But it is a. She literally just said.
I wasn't paying attention. I was doing the work.
You could still hear.
No, you can't. I'm dead.
You get so confused.
Proportional? No. So what makes a line proportional? What are the 2 things that have to happen?
Go to the origin and be a straight line.
Perfect.
Boom, bam, bop.
So it doesn't go to the
No.
Wait, what if I roll on the quiz goes through the 0?
I'm going to be pretty easy on that question.
Because I forgot what it was called. What is it called?
That question I'm going to be pretty easy.
There's double equation.
Yeah, only put straight line there.
Actually.
Wait, there's a double equation.
Oh my god, stop playing with it.
On a scale of 1 to 7, how
Oh,
old?
I didn't realize you had this.
Okay, we're good? Okay, now, sometimes your unit rates are kind of funky numbers. So what do we do when they're funky? Well, we'll discuss. Okay, page 26. The following are apples needed to bake a certain amount of pies. So 1 pie requires 3 apples. So how did I go? So what if I can't graph it? Like there's no graph for me to see if it goes through the origin and it's a straight line. So what you do is like, did I multiply, what did I multiply 1 to get to 3? Times 3. So did I do that for all of these? No. Where did we mess up?
3, 10.
That's where it went wrong. Do you guys see that? So here to here, I multiplied by 3. here to here, I multiplied by 3, but right here, I did not. So as soon as it like does not work for that unit rate, you don't have a proportional relationship. This line wouldn't be straight. It would be like, there would be a hiccup. All right, now look at number 2. What did I multiply 7 to get to 3?
You can't multiply to 7.
I can't. Now, does that mean that it's like not proportional? No, I'm done? No, that means they're trying to trick you. Okay?
Oh, you're multiplying all the way times 3.
Yeah, but is there a relationship between your x and your y? Not your y's, not your x's. So, here's what you do. You are going to...
Oh, I see.
Yes?
It's, so I think the 7 is multiplied by 3 and the 3 multiplied by 3 after, right?
Is there a relationship between the x going to the y?
Oh, okay.
Not like Ariel said, like all your x's and all your y's. I'm looking for a relationship from here to here.
Yeah,
Kind of
7
like
times 3.
when we did this, times 2 times 2 times 2, we went this way. So this arrow that I'm doing here is the same arrow. It's just formatted differently. Your table went from this, looking like this, up and down, to now on its side. But it's the same thing. It's an XY table. Okay, do you remember how I told you to divide? What letter goes outside? The X. What letter goes inside? Okay, can you write this with letters as a fraction? So how would you translate this as a fraction? What would go on top?
X. No, wait.
X over Y.
In and out.
Y over X. No, it's Y over
Yeah.
X.
Y
So
over X.
Y, yeah, Y over X.
Because the top one always goes in.
I heard it, in and out. So it is not X over Y. It is Y over X.
I was about to say that.
Okay, so put all of these as Y over X. So what would I write down for my first set?
3 7.
3 sevenths. Can I simplify 3 over 7? Oh, no. Okay, what would this fraction be? 9 over 21.
You can simplify that.
What can I simplify it by?
3
All right, let's do it.
37s.
Oh. Let's try the next one. What's my first fraction? 12 over 28. Can I simplify that?
Yep.
By 4. What do I get?
Oh, yeah.
Oh, okay, I get it.
Okay, the next one. What can I divide by? My goal is to get 3 sevenths, right? So if I simplify by 2, I'm going to make it smaller, but I'm not going to 3 over 7. 6, and you get?
3 over 7.
So, do they all match?
Yep.
Yes.
Proportion.
So this is proportional. Does anybody know what my unit rate is?
Oh, Y equals 3 7.
Yeah. This would be your unit rate. Is there any way to figure this out by going, what do I multiply 28 to get to 12? No way. It's 3 over 7. So the equation for this problem, let's fit it somewhere in here, would be Y equals 3 over 7x. This is what you're going to have to do when the unit rate is not a very nice number. It's very hard to tell. So what we do is we set them up as fractions and we simplify them. All right, number 3. What did I multiply 14 to get to 4? I have no idea, right? It's not a nice number. So instead of giving up and going like, oh, it's not proportional, what you do is you set up fractions. So what's my first fraction for number 3?
4 over 14.
4 over 14, and I got to simplify this.
Divide by 4.
No.
No.
2. What do we get?
2 over 7.
So I need the rest of these fractions to simplify to 2 over 7. If they all simplify to 2 over 7, we have a proportional relationship. If they don't simplify to 2 over 7, then we do not have a proportional relationship. Which one? The 8 over 28?
4.
This one's divided by 4.
Yeah, it is.
This would give you 2 over 7. Yep.
Oh, wait, yeah.
And then 10 over 35 divide by 5. They're all 2 over 7?
Yeah.
And then what'd you guys do? 12 and 42. What'd you divide by?
Divided by 6.
All right. So they're all 2 over 7, right? So it's yes. So therefore you can write an equation. What would be our equation for this problem? X. I can see this question being like a multiple choice. Like they give you the table and then like this would be A, B, you know. And then some kids would look at it and be like, oh my god, it's a fraction. I don't know. Let me just guess. When in reality, it's not very hard to figure out the unit rate. It just looks a lot harder. It looks a lot harder. All right, number 4. Number 4. What's my first fraction? 9 over 5. Can I simplify 9 and 5? No. So then I'm looking for all of them to equal 9 over 5. Huh?
Why don't we just keep it like 5 over 9?
It's y over x. It's always y over x. Make sure you get in the habit of putting y. Kids will put it as x over y, and no, it's y. Do I want to change it to a mixed number? No, keep it as improper. So 18 over 10, 27 over 15, 63 over 21. I'm looking for them all to be equal to 9 over 5.
Yeah, divide by 2.
The last one. What can we divide? Oh, by 7.
7.
Oh, yeah.
So see if those all equal 9 over 5. 9 over 3, which is equal to 3 over 1.
Yeah.
So right there, this is the one. So this would be a no. So, and then what do kids sometimes do? They'll go yes, yes, yes. I won't do the last one. I'm sure it's a yes. And then they get it wrong. You did all of this work, and they always get you. So don't. All right, let's do page 27. I'll leave you guys alone for a minute. This is the table went from this to this. Is it the same thing? Yes. Okay. Can we find the unit rate?